Hey, what's happening, guys? Got a kit build for us today. This is from eBay, and it is a signal generator, a waveform generator. Yes, my name is Paul, and I have a problem. I am addicted to signal generators. I now have like 3 of them, and I'm about to have another one. I can't help it. They're fun. So this one uses an Atmega 16A PU. It's got a 16x2 LCD. And we're going to put it together. So, let me get my stuff together, and we'll be back to build a kit. Alright, I've got all my parts laid out, and we're going to start from small components to big components. So I think we'll probably start with resistors. This is a 220 ohm. Now this thing is chock full of resistors, so what I'm going to do is I'm going to put in the odd resistors where there's just 1 or 2 of them first. And once I get them in, then we'll move up to the bulk resistors. There are 810K and it looks like 820K. This is a 12. Where does it go? Uh-oh. We almost had a little problem there. Okay, so the 100R goes down there. And then the 12K goes up here. In you go. There we go. The little buggers in there. And then we got a couple of 100Ks. They go right there in the center of the board. Yeah, my neighbor is cutting their grass, so I apologize if you hear the lawnmower, but not much I can do about it. Okay. So there's all of our oddball resistors in place. We'll stick that down there. And I got some new solder I'm going to try today. This is from MG Chemicals. It is 6040. The half pound of it, 0.032 inch diameter. That's 22 gauge. And this was like, I think $11 from Amazon. So we'll give it a shot and see how it does. I don't mind trying off-brand solders as long as they're not lead-free. I really hate that crap. So let's see what we got here. I mean, yeah, it seems to be doing the job okay there. 60-40 generally what I like to use. You know, beyond that, try not to be too picky. As long as nice and narrow gauge, I don't like do my electrical soldering project, or electronic soldering projects with like solder thick enough for household wiring. Alright, yeah, that seemed to have went in quite nicely there. So we will bite off the legs. This kit, like I said, I got it from Amazon, or not Amazon, eBay. Well, it looks like I forgot that one. Right around, I think, $10, $11. Like I needed another signal generator, but I don't know. I got a thing for them. It's like a fetish, I guess. Alright. We flip this over and see if I got them all. Yeah. That's pretty good. So what I'm going to do now is solder in these ganged resistors, and then I'll be back. Alright, all the resistors are in. That went really easy. Let's do the 104 caps. These are monolithic ceramic capacitors, and they go right up here. Bend those legs out a little bit. I'm not sure how this got shipped here from China, possibly on the back of a whale or something, because these parts are all a little bit bent out of shape, and it looks like this thing had a tough time getting here. Guess that's what I'm trying to say. Anyway, this MG Chemical solder, I like it. Seems to be working out pretty well. So there are those two little capacitors in. We have two more. There's very few capacitors here. This, I mean, if you look at the parts count for this, you know, you can see relatively easily that everything here is just handled by the microprocessor. So let's do the crystal next. This is a 16 megahertz crystal, and crystals are non-polarized, so you can flip it in any way you want. I always put it in with the lettering, you know, reading right side up, just because that's how I am. And then we have two 22 picofarad loading caps for the crystal. We'll put those guys in next. I like these red PCBs from China. They're very nice to work with, but if you make a mistake, you're not going to get a lot of chances to correct it, because the traces, or the solder pads rather, they do tend to come off pretty easily. So I'd say maybe you get one correction. Go any further than that, and you'll be cutting the solder mask off to make things work, you know. All right, what next? How about some switches? This is using those tall tactile switches. Alright, I'm gonna... Oh, there we go. I was gonna say I'm gonna take a minute and put these in, but he decided to play alright. But just the way all the legs are bent. I wasn't sure if I was gonna have to futz around too much to get everything to fit. And actually, yeah, I'll be back when I get these in, and then we'll solder them up. Well, that didn't take as long as I thought, but still no reason to make you guys sit around and watch me futz with stuff. So today is the 4th of July, Independence Day here in the US. Saturday was Canada Day, Canada's 150th birthday. Happy birthday, Canada. And I know that I promised today we would have the drawing for that Fluke multimeter. And we are. We're definitely going to do that in this video. I didn't want to put it at the beginning, because then you'd maybe just watch the drawing and go away. And I'm not going to put it at the end, because maybe you figured you'd just skip to the end if it wasn't at the beginning. So it's in here. It's going to make somebody very happy. That's a really nice meter. Fluke is, you know, top of the line equipment. Alright, so there is all of our switches. Alright, how about we do the pots next? There is a 50 and a 1K. This is the 1K, which apparently owed somebody money because all of his legs are broken. Oh, you don't want to stay in the hole. Well, we have ways of dealing with that. What else was I going to tell you guys? Oh yeah, I got a scope meter in. It is not the Fluke scope meter, of course. I mean, you know, that thing's really expensive. This is a Chinese scope meter, and we will have a review on that coming up this week. I got the software defined radio in. Unfortunately, I live between two brick buildings, so the little antenna that comes with it is not satisfactory. So I ordered a 10 meter dipole antenna. The antenna itself is not 10 meters. It's for the 10 meter band. The antenna is 16.5 feet. There we go. Oh. There we go. I am strong like horse. There is no problem here. Alright, how about some BNC connectors? Also got in just today, or actually yesterday, the ESP32. So that's pretty cool. Video coming up on that here in the very near future. Oh, Paul, you dumbass, you're supposed to wait for it to cool. Did you cool? Can I pick it up now? Okay, yeah, and it's flat. That's all I was checking for. Just wanted to make sure it was flat. There we are. Those are some big solder pads, and those support lugs you can see on there, those are pretty thick. Those are around 1/8 of an inch. So they take a bit of heat. There we go. I mean, we're almost done here. This should be a pretty cool little signal generator. The only bad thing about it is, and I'll show you that in a second, is it doesn't have onboard voltage regulation. So you can see here that it wants plus 5 volts, plus 12 volts, minus 12 volts, and ground. So that can be a bit of a pain in the tuchus, but we'll handle it. Okay, next I'm going to solder in the chip sockets, and I'll be back. Alright, as you can see, we've got 99.9% of the soldering done. I think I'm just going to solder some wires onto here for now. So we've got all the switches in, we've got the pots, the BNC connectors, and the sockets for our chips, and the socket for the LCD screen. And if we turn it, whoa, what's that? A name, which I am not going to try and pronounce because I will probably ruin it, and I don't want to insult you, because you are the winner of the Fluke multimeter. Get in touch with me via private message or email, and we will arrange for delivery of the Fluke multimeter to you. Anish? Alright. Alright, so next up we've got to put in the chips. And chips, to me it seems anyway, seem to come a little bit splayed out. And there are tools you can buy. I find if you just give them a little roll on your desk, kind of like that, generally they will choose to fall in line and behave. So there's that one. That's an LM358. And then for our processor chip, oh yeah, that's got some serious bending going on there. And alright, where's our divot is there. Let's line everything up. Yeah, that's not bad. Then we can plug in our screen. But first I want to put in these supports that go on the bottom. Just some brass standoffs. Just want them finger tight for right now. I will tighten them up more once we have the screen on. And it just plugs in like that. And we can drop a couple more screws in here to secure it. If I can get my fingers to work. There we go. One more. Whoopsies. Almost lost that one. Now we'll just make sure everything is nice and snug. Alright, well, I need to figure out a power supply for this, so give me a moment and I'll be right back. Okay, I think we've got everything together. We've got this blue wire, which is our plus 5 volts, the red wire, which is our minus 5 volts, plus 12 volts, the yellow wire, which is our minus 12 volts, and this green wire, which is the ground. It's powered up. Oh, look at that. I believe it's working. Let us connect a BNC cable to the DDS out. And figure out how to turn it on. Alright, start. I say because I am now looking at my scope. And that does not look like 1,000 hertz sine wave. Does it need amplitude? Let's find out here. Ruh-roh. Well, let me figure out what's going on. I'll be back. Well, I don't know exactly what's going on here. I've been dicking around with it for about 10 minutes. And so far, I can get the high-speed square wave output to work, even though they look like shit. There is 1 megahertz. There is 2 megahertz. 4 megahertz. Yikes. And 8 megahertz. So those work. Turn that off. Now I'm going to switch the connection over to the DDS output. Now this says random noise. Random noise is on. And as you can see, there's nothing. Here's a 500 hertz sawtooth. Nothing. 500 hertz triangle. Nothing. Wait a minute, maybe there's something there. Let's do an auto set. Oh, look at that. Pardon my camera rig kind of failing here. Although it says 13 kilohertz. Let's bump it up to... I ain't bumping up to nothing there, is it? Alright. 1 hertz triangle wave on. Wow. It really doesn't want to trigger. The DC offset does nothing. Here's a 1K square wave. Alright, I mean, other than the noise. And the offset does nothing. Amplitude, yeah, the amplitude works. That is one unbelievably ugly signal, though. 1K sine wave. Wow. Turn this up here. Go up to a 10K. Wow. I don't know. I think I would call this garbage. Oh well, you win some, you lose some. And, you know, one lucky guy today, Anish, he won. Alright. So that being said, that's going to be the end of this video. Give me a thumbs up if you liked it. Comment, share. Don't forget to subscribe. And I'll see you guys next time.